everyone, I am Vernal Montuya. So for this video, I'm gonna do the learning activity 2, which is instructional video. Once drugs are inside the body, how do drugs move around the body to get to where they need to go? Do they stay in the body infinitely, or are they eventually removed from the body somehow? The study of pharmacokinetics deals with precisely issue, and in the learning about this, we can highlight the 4 main processes: the absorption, distribution, metabolism, and excretion. Absorption generally describes the way the drugs moves from the site of administration across one or membranes open into the bloodstream if was not administered directly. Distribution describes its journey through the bloodstream to reach target cells and to specific target molecules within. Metabolism describes the ways that eventually modified by enzymes and rendered ineffective. Excretion describes the way that exits the body, typically either urine or feces. You want to understand each of this process as well as the ways that interaction with food, drink, other drugs, and additional factors can have influence on them. First step is absorption. If the drug is administered, typically this could mean moving through the skin or a mucous membrane, and subsequently through the walls of near and blood vessels. If administered orally, this could mean absorbed through the lining of the stomach or intestine, a process which would be slowed by the presence of food. Some drugs will pass through the cells that comprise the membranes by the passive transports or other active transport by one way and another. They will make it through on the way to their destination. In describing this process, it would be appropriate to review the term bioavailability. This term describes the proportion of a drug that is successfully absorbed into systemic circulation. Emission distribution. This describes the way that drugs move through the bloodstream after being absorbed into it or injected into it. There are many factors that influence, like the way that the drug interacts the components of blood, such as plasma proteins. If the drug binds too tightly to these proteins, it will not be able to reach its target cells. Sometimes a second drug is administered in conjunction with the first that has a higher affinity for the proteins than the first one does, serving the purpose of displacing the primary drug once bound to the protein, allowing it to be delivered to its destination. These blood elements, there are other factors that may hinder the movement of a drug. There are anatomical barrier found in central organs. We have already discussed the blood-brain barrier in the biopsychology series. This prevents certain substances from passing out of the bloodstream into brain tissue. Some drugs were not able to surpass barrier, while others, such as psychotropic drugs or those affecting the mind. There are also the blood placenta barrier that regulates which the substances can pass from the bloodstream of a pregnant woman into the fetus. There are, however, a number of substances that are able to pass through this barrier that can still do harm to the fetus, such as alcohol and certain medication. And then, there is the blood testicular barrier, which prevents many substances from reaching the male testes, therefore making disorders of the testes difficult to treat. After distribution, there is metabolism. This describes any chemical reactions that the drug may participate, often aimed at inactivating it and targeting it per excretion. A drug is traveling through the bloodstream, it is highly likely to be metabolized to some degree. For example, if a drug is taken orally, it will be absorbed through the intestinal wall, and for this reason, the part of the circulatory system it enters is a collection of blood vessels called the hepatic portal system. This carry blood directly to the liver, where they will metabolize in some manner. This This is called the first pass effect, referring to the first pass of a drug through the liver, and this will typically greatly reduce the bioavailability of a drug. In a certain cases, metabolism in the liver actually activates a drug, but this is less common, and the first pass effect can inactive over 90% of and must be taken into account when determining appropriate dosage. Of course, drugs eventually reach their target cells, but even then, after enough time elapses, they will be metabolized. There are many different enzymes in the body that perform these metabolic functions, which are very important because the immune system is only good at dealing with large biological particles like viruses or bacteria. It has no defense against small molecules, so this detoxification mechanism aims significantly at small molecules had to evolve for life to exist in a chemical world. Finally, after metabolization, there is excretion, where the drug or its remnants exit the body. This is typically done via exhalation, sweating, urination, or defecation. The kidneys are heavily involved in this process as they must remove harmful substances from the bloodstream. Some drugs are metabolized into gaseous form and are thus easily exhaled. Some drugs are excreted through bile, a substance secreted by the liver to aid in digestion. As bile is recirculated back to the liver via extrahepatic recirculation, whereby most of the drug can then be excreted by the kidneys, and the rest will exit in the form of, and as we said, glands that produce fluids such as saliva and sweat can also promote excretion. So this method tends to be less effective. And with that, we have traced the journey of a drug into the body, around the body, and out of the body, which give us a basic understanding of pharmacology.